Bimetallic strip. Next application. So bimetallic strip. Eighth application or ninth?
18th material.
Very important application. Today, two applications also important: bimetallic strip and measuring scale. So maximum for derivation part completed. Next one, theory applications. Last but one application, bimetallic strip. Bimetallic strip.
And applications.
Bimetallic strip means when two different metals, one over the other, are revived together. When two different metals, dissimilar or different metals, are revived together to form a single strip is called bimetallic strip. Okay, two different metals or different materials. And it is a combination of two different metals are revived together. Two different metals are revived together to form a single strip. Single strip. To form a single strip is called bimetallic strip. To form a single strip. So this is called brass. For example, brass, steel. So brass 18 into 10 power minus 6 per centigrade. Alpha value, alpha brass. Alpha steel. So 11 into 10 power minus 6 per centigrade. Alpha steel. When two different materials are revived together, revived means one over the other. Revived together to form a single strip is called bimetallic strip. Okay, single strip is called bimetallic strip. Okay, so brass has higher coefficient of linear expansion. Steel has lower expansion. Coefficient of linear expansion. Brass has 18 into 10 power minus 6 and steel has a lower low coefficient of linear expansion when compared to brass. So different materials have different linear expansions. Refer in table in Akash material. One table is there. Akash material some page. Okay. Table also there. Values, alpha values are there. Alpha values. Right.
12, sir, page number 12.
Right. Aluminium, brass, copper, iron, glass, okay. Lead, steel, inverse steel, 0.9 into 10 power minus 6. Okay. So like silver, gold. This is the one table is there. Table. Okay. Akash material, refer Akash material.
We need to remember, sir.
Brass,
Sir, avani నేర్చుకోవాలా sir?
No need. No need. Just idea until high value. So brass and steel, brass is more, so steel is less. So more expansion of material is, for example, on heating and cooling or heating. So more expansion and more contraction. High expansion of linear, high expansion, high linear expansion. High linear expansion, expansion of the material, more expand and more contract. More contract. Due to heating and cooling. Okay? Heating and cooling. So more expand also more, both. So more expansion of coefficient of linear expansion. Okay. Second one is on heating. On heating, okay, this is the brass. On heating, this is the brass one. This is the steel. On heating, this is the convex shape. So on heating, brass more expand. Brass more expand. On heating, brass more expand than steel. Okay. So on heating, brass expands. Brass more expand than steel. So that is alpha value. So alpha value is more. Okay. So alpha value is more. For alpha more value lies on outer side. Outside means like convex shape. So alpha more value and alpha lies on convex side. Alpha lies on convex side. First on convex side. Alpha more value lies on convex side. Okay. Alpha more value means brass. Brass on convex. This is the convex side. So convex side means outer side. This is the important. So outer side. This is a very, very important. Okay. On heating, brass more expand than steel. So that is alpha more value lies on convex side. And the convex side. That is outer side. Outer side of the steel. Bimetallic strip. Okay. So next one, third one. On cooling. Brass more contracts than steel. So that is, this is the shape reverse. This is the brass, this is the steel. More contracts. Same, that is alpha more means brass lies on concave shape, concave side. So that is inner side. Inner side of the steel. So inner side of the steel. Very, very important. Gunshot. Is the concave. Concave means is concave. This is convex. This is the convex. This is the concave. This is the convex. This is the concave. Okay? Convex, concave. Lens.
Sir, dosa pan is there, no, sir?
Huh?
Sir, pan, heating pan.
On cooling, on heating.
No,
This is
sir.
on
No,
heating.
normally I'm telling, sir, pan is formed by riveting. No, sir.
Why? After completion, you first tell me. First topic not completed. Is first or completed?
Yes, sir.
So this is the bimetallic strip. Bimetallic strip is a different metals. Pan is only one metal. This is the bimetallic strip means two metals. You observe this is the two metals, not a one metal. Two metals.
Yes.
So this is the brass and steel. This is the bimetallic strip. Pan is the only iron or steel. Only one metal is there.
Yes.
Okay. First completed. Topic after completed. Any doubt? Ask me any doubt. So on cooling, so brass is more contract than steel. So this is the concave side is brass. So steel is outer side, inner side is brass.
సార్ సార్ జరగండి సార్ కొంచెం ఒక్క నిమిషం.
First one, number of applications are there. Actually remaining.
Yes, sir.
Yes, sir. Continue.
Continue.
Right. Next one. Next. So bimetal, what is the bimetal strip? When two different metals are revived together to form a single strip, is called bimetallic strip. So on heating, so bimetal strip in the form of convex shape. So convex shape means outer side is the brass. So high coefficient of linear expansion. So inner side is low expansion, low coefficient of linear expansion. This is the important. On cooling is a concave shape. This is a concave shape. So inner is a more expansion of material. So outer side is low expansion of material. This is the important. Okay. So 3 points. So next one, bimetallic strip. So fourth one, bimetallic strip is used in thermostat. Thermostats means actually automatic switches. For example, this is a bimetallic strip. So bimetallic strip, this is a bimetallic strip. It is heated. So it is heated, is bent in the form of this is a shape. So for example, is connected to, this is a connected, this is a connected. First one initial is connected. This is a bimetallic strip based on instrument. For example, this is a connected to one battery. Okay. So it is a bimetallic strip. It is heated. So bent in the form of semicircle. So at that time is not a contact. So bimetallic strip is off. For example, this already initially is connected to this one. So on cooling, this is also reverse process. For example, this is already is bending. So bending is on. For example, this is cooling at a room temperature in the form of a slight. The first bending, this is the connected. So next one, on cooling, this is the also disconnected from circuit. So bimetallic strip used in either on and off system. Also.
Automatic on-off, sir.
On-off system, either on or off. Okay, na? Bimetallic strip used as either on or off. Okay, right. In thermostats, for regulating heating or cooling, thermostat. Thermostats. Okay, only thermostats for regulating heating or cooling of rooms. Heating or cooling rooms. So thermostat is used in Bimetal strip is used in thermostats for regulating heating or cooling, either heating or cooling. So next one, this is the A, B. Okay, they are used in fire alarms. Fire alarms, same previous one. For example, initially is certain temperature. For example, normal temperature is connected. So temperature also increases. Temperature increases. So is the contact leave the contact. So is a off. Or for example, anyone based on room depends on instrument. So they are even fire alarms. Fire alarms. Fire alarm. They are used in fire alarms. So the bimetallic strip are used in fire alarms. Fire alarms. So third one are used to open or closed. Electrical circuit. Open or closed. Electrical circuit. Right. So they are used to open or closed. Are used to open or closed electrical circuits. Okay.
Sir, fire ఏంది సార్ అది?
Fire alarms. They are used in fire alarms. Okay. This is the uses. So bimetallic strip are used in thermostats for regulating heating or heating is the A. Heating or cooling of rooms. So second one is fire alarms. So third one is open, are used in open or closed electrical circuits. Open or closed electrical circuits. So this is a bimetallic strip. And a stabilizer also, they are used on stabilizer and refrigerators are based on this bimetallic strips. Okay. What is the principle? Very, very important. Fifth one. Unequal expansion of unequal expansion. So unequal expansion of dissimilar metals. Unequal expansion of dissimilar metals. Dissimilar metals. Just wait a minute. Is correct or not? Dissimilar metals of okay, right. So dissimilar metals is the heating is the principle and is on heating like better. Dissimilar metals on heating is the principles of thermostat. Principles of thermostat. So principles of thermostat. What is the uses of bimetallic strip? Bimetallic strip are used in thermostats, or regulating heating or cooling of rooms. So they are used in fire alarms. So they are used in open and closed electrical circuits. These are the uses of bimetallic strip. Are used in refrigerator and automatic switches. Okay, right. So next one is the principles of unequal expansion of dissimilar. Unequal. Not a. For example, one is the brass and both are not equal expansion. So one is the brass, another is the steel. So 100% to different materials. And a brass, not a two brass, not a two steel. So dissimilar metals must and should. Two dissimilar metals, uneven expansion. So unequal expansion of dissimilars on heating is the principles of thermostat. And not as, for example, two bimetal strips means two brass strips are riveted together. Is not a bimetal strip. Not a two steels, two brass, two iron. You know. So bimetal strip means 100% two different materials is must and should. So different materials and coefficient of linear expansion also different. So not SM is different. So different coefficient of linear expansion of materials are riveted together to form a single strip is called bimetal strip. It is based on the principles of thermostat. Right. So right, next one is the sixth one. For example, this is the one bimetal strip. So two different rods. One is the iron, another is the copper. This is the copper. Copper. This is the iron. Iron. So iron. So iron is the coefficient of linear expansion is 12 into 10 powers minus 6. So copper is coefficient of linear expansion 17 into 10 power minus 6. Okay. Is placed in vertical position. For example, on heating, which side is bending? Tell me an answer. Which side is bending?
Copper side.
Left side.
Copper side, sir.
Without bending, straight line, without any change. Without any change.
Side, sir.
Either left side or right side, right or left. First right and bend in left. Tell me answer.
Sir, right side.
Right side.
Sir, first right side.
Right side, sir.
Sir,
Right side.
first right side, sir.
Right side.
Yes, sir.
Right
Right
side is
side.
correct? Right side is correct.
Left.
Right side only.
Left.
Right
So
side.
this is the one bimetallic stick. So it's placed in vertical position. So the one is the iron, another is the copper. Copper is the coefficient of linear expansion is 17 into this is the copper. 17 into 10 power minus 6. So iron is
Less.
12 into 10 power minus 6. On
That
heating, not a cooling. On heating. On heating.
left is third.
Right side, sir.
So alpha of copper is greater than alpha of iron. Right side.
Sir, left, sir.
Huh?
Left.
Sir, right.
It bends left. It bends left. Left side. Why no? Left side. Okay, clear?
More expansion.
So on heating, outer side is more expansion. Outer side is more expansion. Okay. Left is, for example, this is the bending. For example, this is the bend. This is the bend. Okay. This is the bend. So this is the copper. Okay. This is the copper. This is the iron. Okay. Iron. So this is the iron. So on heating is important. On heating. So on heating, alpha copper is greater than alpha iron. It bends the left side. So because more expansion of material is in outside. More expansion, more alpha material is an outside. Material is outside. Material is outside. So this is the diagram. Okay, seventh one. Same. For example, this one. This one. X and Y. Left side is X, right side is Y. On cooling. This is also on cooling. On cooling. Alpha X is more than alpha Y is given. alpha x is more than alpha y. Which side is bending?
Left side, sir.
Left.
Left side, sir.
This also left.
Yes, sir.
Yes,
But
sir.
pulling no, sir.
It will bend. It will bend. It will bend
Right side.
towards left.
Left.
Towards left. Towards left. Because alpha value is greater. Cooling. Cooling means inner part, inner side. So more alpha value is inner side. Is very important. On heating, more alpha value outside, more inner value is a concave shape. Cooling means concave. Heating means convex. Convex means alpha value outside. Okay. So cooling means inner side. These are very, very important. So it bend towards left because more alpha value, more alpha material inner side. More alpha material inner side. Inner side.
Sir, can you move aside? Can you move aside, please?
Right. Is it clear? So this one, and this is the same bending. This is also same. X. This is the y. X, y.
Sir.
On cooling, no. On heating. This is on heating. On cooling. On cooling. These are different. On heating, on cooling.
Sir.
Tell me.
Sir, till his mic to off, sir. His mic is on. It is disturbing.
Your mic or my mic?
Cynical mic, sir. His mic is on. He is disturbing.
Disturbance. So remove it. Okay. Remove from cynical. Cynical.
He muted, sir.
Right. Okay. No. This is the thermostat. No? So bimetal strip. What is the bimetal strip? When two different metals are revived together to form a single strip. For example, this is the brass, this is the steel. Both are revived together to form a single strip. Is called bimetal strip. On heating in the form of convex shape. Convex shape means outer side is the more expansion of material. So inner side is the less expansion of material. This is the important. On cooling, same. This is also in concave shape. In concave shape means so inner is a more expansion of material. Outer is less expansion of material. This is the important. So thermostat bimetal strip can be used in thermostat. So thermostat are heating or cooling in a room. Cooling in a rooms. So next one, they are used in automatic switches, refrigerators. Next one, on and off and electrical circuits. And their fire alarm, they are used in fire alarms also. This is the use of bimetal strips. So bimetal strip is based on the principles of uneven expansion. Uneven expansion of materials are revived together. Uneven expansion. And uneven means different materials are revived together. This is a very, very important is the principles. So principle is very, very important. Unequal expansion of dissimilar materials are taken. So it's called principles of thermostat. Is very, very important. So when copper and iron are revived together, are placed in vertical position. So on heating, this is the bimetal strip bent towards the left side. So because of towards left side is the copper is a more expansion of linear expansion than iron. So is outside part. So more expansion is outside. This is a convex state. So outside. So it bends left side. So same model on cooling. On cooling, alpha x is more than. We observe first which value is more. Which value is more. So alpha x is more, alpha y is more. Alpha x is more, for example, alpha y. So refer Akash material first exercise 1. So exercise 1, all bits are covered. Exercise 1, all theory bits are covered. So this is the not a one. This is the exercise 1. Exercise 1. Right. Exercise 153. So 53, 52 and 53. So this is the 52, this is the 53. Okay. So 52, a bimetallic, a bimetal made of copper and iron are welded together. Okay, is a straight. This is also 53, direct. 53. So X and Y. So X and Y. So X is a more expansion of Y. So on cooling means, so it will bend towards left because of inner part. So inner part more expansion. Cooling means inner part is more expansion of material. So on heating means outer side is more expansion of material. These 2 points are shown in our mind in bimetallic strip. Okay.
Yes, sir.
Sir, alpha Fe value in sir. Alpha Fe.
Alpha.
Iron alpha value in sir.
Rasan ada boy.
కనబడతలేదు సార్ నాకు.
12 into 10 power minus 6. ఏం కనబడదు మీకు కనబడదా? 12 into 10 power minus 6. Refer our table or Akash material. So 12 into 10 power minus 6 alpha iron, alpha copper, 17 into 10 power minus 6. Refer our Akash material. Table, one table is there. Right, on heating, on cooling. Right. So next one. So next point. 6th point or 7th point. Radius of curvature calculus. This is only for cover theory bits. Next one, numerical concept. So 7th one, radius. Radius of curvature. Radius of curvature. Curvature of the bimetallistic. Right. Radius of curvature of bimetallic strip. So just a little bit big diagram. Right. This is the brass L1 alpha 1. This is the L2 alpha 2. This is the brass steel. For example, this is the D. D is the center to center. And this is the brass rod, this is the steel. Okay, this is the brass. This is the steel. Steel brass. Right? Right. This is the R, radius. From center to radius. This is the D by 2, diameter. So this is the R, this is the only diameter of this one. Okay. So R plus, so D by 2 is center to 1. So R minus D by 2. Right. R minus D by 2 for steel from center to D minus 2 subtract. R is from center of the bimetallic strip to this is the origin point. Right. D, what is the D? D is the center, center to center. What is the D? D is the distance between distance between centers of strips. Distance between centers of strips. Centers of strips. Okay, center. This is the center. First center to center. So D is the centers of the strip. Okay, right. So first one is next one. What is the angle formula? Angle theta equal to arc length by radius. Arc length by radius. So arc length equal to theta into r. R theta r. So arc length equal to angle theta equal to arc length by radius. Arc length equal to theta into r. Theta into r. So first one L1 length, L1 calculated. What is the L1? So what is the L1? L1 means first rod R plus D by 2. And this is the length and radius into theta. Theta means this is the pi. Same L2 is equal to R minus D by 2 into pi. Okay? So arc length is equal to theta into r. R is the radius, theta is the pi angle. So in this angle is pi. Okay, pi. So angle pi is equal to arc length by radius. Arc length equal to pi into r radius. Pi. So L1 is equal to r plus d by 2 into pi. L2 equal to r minus d by 2. R minus d by 2 into pi. So this is the L1, L2. Okay. Let L0 be the length of the rod at t degrees. Ante normal at length of the strip at 0 degrees. For example, initial 0 degrees at 0 degrees. L0 be the length of the strip at 0 degrees. Okay. So okay, what is the L2 general formula? L2 is equal to L1 into 1 plus alpha. Ante L0 into 1 plus alpha 1 into t minus 0. And each one rod is increases from t to 0. T to 0. So L1 is equal to 1 plus alpha 1 t into 0. This is the one rod. And for one rod. And L1 rod. L1. So what is the L2 is equal to same L0 into 1 plus alpha 2 into t minus 0. Second rod also same. Okay, L2 is equal to, this is the formula, general formula, L2 equal to L1 into 1 plus alpha. So L2 equal to L0 into 1 plus alpha t minus 0. So this is the equation 1, equation number 2, equation number 3, equation number 4. So equation 1 and 2 substitute in equation 3 and 4. Now what is the L1? L1 value R plus D by 2 into pi is equal to L0 into 1 plus alpha 1 into t. So in equation number 5. Same L2 value substitute. And 1 and 2 substitute in equation 3 and 4. So R minus D by 2 into pi is equal to L0 into 1 plus alpha 2t. Equation number 6. Both are dividing. So L0 into 1 plus alpha 1t by L0 into 1 plus alpha 2t equal to R plus D by 2 into pi plus R minus D by 2 into pi. So pi cancel, L0 cancel. So cross multiply. Right. So 1 plus alpha 1t into R minus D by 2 equal to 1 plus alpha 2t into R plus D by 2. So multiply, total term is multiply. 1 into R. So minus D by 2. Next one plus alpha 1 TR. Next one minus alpha 1 D by 2. Alpha 1 into this one, 1 into R, 1 minus, okay, right. Next now alpha 1 TR plus into minus, okay, into T. Okay, equal to. This is also same one. So 1 into R, 1 into plus d by 2. So next one plus alpha 2 TR plus alpha 2 T into d by 2. Okay. RR cancel. Is RR cancel. These are these are cancel. RR cancel. Next one. So d by 2 alpha shifted. Okay, right. So next one, minus d by 2, minus d by 2, minus d by 2. This is also shifted. Minus ante minus. Then this is a shifted to d by 2 d by 2. Alpha 1 t r, alpha 1 t r minus alpha 1 dt by 2 is equal to d by 2 ante d by 2 dt d d like plus alpha 2 tr plus alpha 2 t d by 2. Okay. Next one. This is shifted. So alpha 1 into the d by 2 is plus d by 2. Right. Alpha 1 tr minus alpha 2 tr equal to so d plus dt by 2 is common, alpha 1 plus alpha 2, alpha 1 plus alpha 2. मतलब 2 రావాలి. or 1 into r minus d by 2 alpha 1 t into r minus alpha 1 t alpha 1 dt by 2. Okay. or 1 into d by 2 plus d by 2. Next one, alpha 2 d by 2. There are 2d రావాలి. D by 2. Okay, no problem. Right, this one. Right, multiply with 2 by 2.
So direct
Dividing multiply 2d by 2. Okay. So alpha t is common. Alpha 1 minus alpha 2 is equal to. So d by 2 is common. D by 2 is common. 2 plus alpha 1 plus alpha 2 into t. Alpha 1 plus alpha 2 into t. This is the value. Alpha 1 plus alpha 2 value. This is the value. This is the value. Alpha 1 plus alpha 2 is value is very, very small. Is very, very small. Because alpha values are at 10 power minus 6. Minus 6. Because 10 power minus 6. Each value, each alpha is 10 power minus 6. So this term is removed, eliminated. So alpha 1 plus alpha 2 into t is removed. Because this comparatively to none. This is the comparatively to. So is small when comparatively to none. To. When comparatively to comparison to 2. So alpha 1 plus alpha 2 into t is removed. Removed. This is also removed. 2 cancel. Okay? So 2 cancel. So these are 2 cancel. So 2 cancel. Therefore, alpha T, not this one. This is the which one common? TR, sorry, TR. TR common. So TR common. So TR into alpha 1 minus alpha 2 is equal to d by 2 into 2. 2 cancel. Therefore, so T is equal to d by R is equal, radius of curvature R equal to, so d by, so alpha 1 minus alpha 2 into T. This is the final formula.
The derivation important.
Final formula important. So radius of curvature of bimetallic strip R is equal to, so d by alpha 1 minus alpha 2 into T. This is the final formula.
Sir, sir, that T is in denominator, no?
T.
Yes, sir. T is in denominator.
R is equal to d by 2 cancel, d by T.
Okay.
T is denominator.
Okay, sir.
Is the temperature. So this is the radius of curvature of bimetallic strip. Alpha 1 plus alpha 2 is very small when comparatively 2 because of each and every alpha value 10 power minus 6. So this term is eliminated. So 2 cancel. So TR into alpha 1 minus alpha 2 equal to d by 2 into 2. So 2 cancel. 2 cancel. So only R equal to d by alpha 1 minus alpha 2 into 2. This is called bimetallic strip, radius of bimetallic strip. D value given, alpha 1, alpha 2 given, temperature given, radius of curvature calculated. Any doubt, Anna? Any doubt? Bimetallic strip completed. Any doubt? 10 minutes, any doubt? Bimetallic strip.
Sir,
Tell me.
నాకు బయోమెటాలిక్ స్ట్రిప్ కాకుండా వేరే డౌట్ ఉంది సార్.
ముందు బయోమెటాలిక్ స్ట్రిప్ ఎనీ డౌట్ అన్న ఫస్ట్
బయోమెటాలిక్ స్ట్రిప్ కాకుండా వేరే డౌట్ ఉంది.
టెల్ మీ.
Sir, please move, sir.
No, sir.
Your voice not clear.
Sir, riveted means
ఐరన్ రాడ్స్ ఉంటాయి కదా సార్, ఐరన్ బార్స్ కన్స్ట్రక్షన్ లో వాడే.
Voice is breaking, sir.
Yes, sir.
Sir, riveting means what, sir? Riveting.
Riveting ante joined, sealed. Both are riveted together. Screws. By very minimum knowledge.
Yes, sir.
Riveted screws. These the both are. This is attached by screws. Both are screws. Nails fitted to nails by using nails. Screws.
Yes, derivation important.
Tell me, Anna. Any doubt?
Sir, derivation important.
Derivation not important. Final formula important.
Okay, sir.
సార్, అయితే ఇప్పుడు మనకు రస్ట్ పట్టిన ఐరన్ బార్స్ ఉంటాయి కదా సార్ కన్స్ట్రక్షన్ లో వాడేవి, అవి బెండ్ చేసినప్పుడు హీట్ ఎందుకు అవుతాయి సార్? అంటే ఇక్కడైతే బెండ్ అవుతుందో అక్కడ హీట్ ఎందుకు అవుతుంది?
ఐరన్ బాక్స్ బెండ్ కదా బాయ్, హీట్ చేసే ఎక్స్పాండ్ కదా.
కాదు సార్, మనము నార్మల్ గా బెండ్ చేస్తాం కదా సార్ ఐరన్ బార్స్ ని కన్స్ట్రక్షన్ లో వాడేది.
అవి దాంట్లో ఓన్లీ ఐరన్ ప్యూర్, నాట్ ప్యూర్ ఐరన్, దాంట్లో కూడా సమ్ అదర్ మెటీరియల్ ఉంటుంది.
బెండ్ చేసినప్పుడు బెండ్ చేసే పాయింట్ లా హీట్ ఎందుకు అవుతుంది సార్?
అబ్బాయి నువ్వు ఇటు కొట్టామనుకుని హీట్ కదా అబ్బాయి, హీట్ డెవలప్ కదా. మాలిక్యూల్ ఇంటర్ మాలిక్యూల్స్ ఆర్ మూవ్ ఫ్రమ్ ఇంటర్ మాలిక్యులర్ డిస్టెన్స్ ఇంక్రీజెస్. ఇలా ఇలా టచ్ అయిపోయి ఫాస్ట్, ఓకేనా. సో దిస్ వన్ అక్కడ కూడా హీట్ డెవలప్ అవుతుంది.
ఓకే సార్,
అది అసలు డౌట్ కదా అబ్బాయి, టైం వేస్ట్ చేయకూడదు. రీజనబుల్ డౌట్ అడుగు అబ్బాయి. సో కంప్లీట్ అయినా?
Yes, sir.
Basic knowledge అబ్బాయి. Intermolecular resistance, atomic distance is increases, so the additional energy is added to it. So precious
corona batch చాలు మరి ఏం
sanity is also temperature also increases, is a minimum. అబ్బాయి మినిమం డౌట్ కూడా అడుగుతుంది. బాడీ ఎందుకు హీట్ అవుతుంది సార్ అంటావు? టైం పాస్ డౌట్ అడగద్దు అబ్బాయి, రీజనబుల్ డౌట్ అడగదు. నెక్స్ట్ వన్ అండి, measuring scale. So next application, very important, measuring scale. Right, expansion of measuring scale. Expansion of measuring scale. Expansion of measuring scale. So next one is expansion of measuring scale. So only 2 days left to next. Liquids also there. Okay. Solids not completed. Next 4 or 5, next 5 or 6 applications are there. So next one, expansion of measuring scale. Okay.
So only 3 minutes left.
Only 3 minutes. This
Sir,
is
zoology class cancel అయింది సార్.
Sir, tomorrow continue.
okay. Next
అంటే మీకు
3
ఇప్పుడు 10
minutes. This is the wood. This is the wood. No, another class there.
Okay.
Here aims.
Okay, sir.
Right. This is the scale. Scale 1, 2, 3, 4, 5. 1, 2, 3.
Sir, plastic scale also.
0, 1, 2, 3, 4. This is the scale. This is the wood. Wood, any wood material is placed. Wood means this is the object, considered as object. Is placed nearer to the scale. Scale at a temperature is T1 degrees. This is the temperature is at a temperature. Temperature is T1 degrees. So first one, scale is calibrated. So calibrated. Calibrated at a T1 degrees. What is the calibrated means? Made of scale. Scale is made of at T1 degrees. Calibrated means made of scale. Scale is made at a temperature is T1 degrees. Okay, na? These are scale. Scale is actually 5, 6. First one, object length is 5 centimeter. So at calibrated temperature. At calibrated temperature means T1 degrees. So next one, it is heated. Temperature also increases. So temperature increases, scale also expand. So object, for example, this is the object. Object no change. Wood is the same. But scale also expand. Scale expand means the length is also 4. So 3, 2, 1, these are 0. So actually this is the 5. But wood, this is the wood. Scale also expand. So length also, measuring length is short length. These are only 4 centimeters measured. This is the measured value. This is the true value. So measured value is always less than true value. This is also true value. Length of the true value. This is the true value. True value means accurate value at correct value. Correct value to T1 degrees. This is a measured value. Measured value is only 4. So true value is 5 centimeter. But this is the temperature increases. So temperature is, for example, this is a 2 degrees C. T2 degrees C is more than T1 degrees. So this is the length also decreases. So therefore true value is equal to, so this error, this is the error value. And the measured length of the measured value plus error. And some error value. And a delta L. What is the delta L? Delta L equal to L alpha delta T. L alpha delta T. So that is equal to L to measured value plus delta L will means L measured value into alpha scale of the coefficient of linear expansion into delta T. So this is the L of true value. So temperature is increases, so error value is added. So for example, temperature decreases, the error value is subtracted. So next class we'll continue again. So just to briefly explain.
Formulas.
Okay.
Sir, that error in units and measurements.
Tell me. Error equal to L alpha delta T. Temperature increases, error added. Temperature decreases, error subtracted. Error means L alpha delta T. Change in length.
Yes, sir. Done.
Sir, మనకి expression of solids లో only alpha వరకే ఉంది సార్.
Okay, alpha. Right.
అదే సార్.
Sir, tomorrow
Thank you,
you
sir.
teach this.
Thank you, sir.
Thank you, sir.
Thank you.
A small gap is left between two successive railway tracks. Why? This is the railway track, Nana. A small gap between
Summer they expand, sir.
in summer to allow the expansion linearly. Right. Okay. To allow the in summer to allow the expansion linearly. To allow the expansion so linearly. So gap should be left between two successive railway tracks. Okay, successive railway tracks. This is a very general applications. First one is a small gap is left between two successive railway tracks. First question. Theory questions or IP question? IP 2 marks question. So a small gap between two successive railway tracks. Why means in summer season to allow the expansion linearly. To allow the expansion linearly. So without gap, for example, without gap, both are expand and both are contact, both are collide, and tracks also. Okay, na? Tracks. This one both are this one move. Is a different direction. Path of the track is changes. Path changes. Not a track. For example, this is another track. Distance decreases. Okay, na? Not this one. So path of changes. Path. So path also changes. So otherwise. So in a small gap is left between two successive railway tracks because in summer season to allow the expansion linearly. Otherwise both are expand. Okay, na? Expand, collide one to another. The path of the track will changes. Clear? This is the first one. Second one. A telephone wires, actual electrical wires and all electrical wires are telephone wires also. Loosely stretched between two poles. For example, this is one pole, this is another pole. And there is a heavy cable from, for example, Warangal to Hyderabad. So line cable, this is electrical line cable. So our telephone cable, one separated telephone cable. Telephone. These are loosely. Loosely structured. Okay, because For example, both are, for example, wire is tightly stretched between two poles. So in summer season expands. So expands, wire will break or poles are fall down. There is either two possibilities. So to avoid this condition, avoid this breaking or fall down, so the wire or cables are loosely stretched between two poles. This is important. Either summer or winter season. In summer or winter season, to allow the expansion and contraction, so wires or cables are loosely stretched between two poles. This is the second application. Okay, right. So right, first one is by a gap between two successive railway tracks. Gap. So third one. Third one, for example, one electrical bulb is a bulb. Okay, this is a bulb. This is a filament. Old bulb and a bold filament bulb. Old. Tungsten filament and red bulb and a red. Red bulbs. Red bulbs there. So red bulbs. This bulb is actually right. Bulbs. Bulb is heated at high temperature. So current flows are heated at high temperature. This is a tungsten filament or mild tungsten filament. It is completely dipped in water without any breaking. For example, this is already heated. So for example, it is placed on any suspended, for example, water drops, cold water, so fall down drop by drop. For example, our cold water is sprinkled on bulb, hot bulb. Bulb will break. The bulb will break down because uneven expansion and contraction. Because all part are expansion, this is the only water drops point is contracts. This is the contract. This point is contracts, remaining part expansion. So expansion, uneven expansion, contraction. So bulb will be break. For example, bulb is completely dipped into water. So so bulb will glow. Bulb will also glow. So no damage. So inside some bulbs also glow inside the water. Some bulbs. So because of total is contraction. Either total contraction or a total expansion is better. Or contraction and expansion is uneven expansion and contraction. The bulb will break. Will break. This is the third example. So fourth one. This is the bulb. Okay, bulb. Platinum wires. This is the platinum. Platinum wires is pushed into glass bulb. Other wires are pushed into glass bulb. Glass bulb will break or the air enter into the bulb. For example, this also expand. For example, wire also expand more than glass. So bulb will break. For example, contracts. Some air is created around the wires, so air enter into the bulb. Bulb is not glow. Bulb is glow, but not visible. Intensity also decreases. So 100% platinum wires is pushed into glass bulb. So because of the coefficient of linear expansion of platinum and glass are same, are equal, approximately equal. Glass and platinum wires of coefficient of linear expansion are same. So platinum wires are pushed into glass bulb. So other wires are pushed into glass bulb, either break or air enter into the bulb. Okay. So to avoid this condition, either breaking or not glow, bulb intensity is decreases. To avoid these conditions, so only platinum wires are pushed into glass bulb. Okay. Right. Another example. So fifth one. For example, iron ring, wooden ring, blood cotton actually in villages. This is also wheel. So this is the wooden ring, wooden ring. So this is the iron ring. So iron is wooden. Radius of the iron ring is less than radius of the wooden ring. First rim is less than. Radius of the iron ring is less than the radius of the wooden ring. It is heated to high temperature. from T1 degrees C to T2 degrees C, high temperature. It is high temperature. So rim also expand, which is placed on wooden rim and allowed to cool by using water. So at that time, the iron rim is tightly fitted to the wooden rim. Tightly fitted to the wooden rim. So this is the one example. So first one, the radius of the iron rim is less than radius of the wooden rim. So the iron rim is heated at high temperature. So at that time, the iron rim is also expand, which is kept on wooden rim. So the wooden rim is tightly fitted to the wooden rim, and iron rim is cooled. After that, which is placed on a wooden rim and allowed to cool. So allowed to cool, the iron rim is tightly fitted to the wooden rim. Clear? Right. Next example. Next one. Okay, first one is a railway track completed. Next one, telephone wires completed. Bulbs completed. Next one, uneven expansion completed. Next one is okay. Old bridges. You observe the old bridges. Old British, 600 BC in old bridges. So not a concrete by using iron rings. So this is the bridge. So this is the iron ring. So first one end is fixed. This is the fixed. One end is fixed. Other end is placed on. This is the ring. This is the iron strip. Iron strip is placed on wheels. So for example, both are fitted. In summer season, expand. So bridge, this is the road or anyone will break. So you observe any cement road or any tar road or any iron road, 100% a small gap. Gap between this. So small iron, wooden, cement road also, small gap is left between two bridges. Under two, this is the one brick and one some length. So each and every some part is a small gap left between because of expansion is to allow the expansion easily. So this is also same. So the iron rim is fixed to one end, other end is placed on wheels. In summer season to allow the expansion easily. So in winter season to allow the contraction. So to summer and winter season, expansion and contraction. So this is the one side is fixed, other side is placed on iron. This iron plate, iron strip is placed on one end is fixed, other end is placed on wheels. Okay. You observe on the old bridges, not a new bridges, old bridges. Right. This is the one example. Next. Next general example. Bimetallic strip completed. Iron rim, okay. Okay, right. This is the one metal strip. This is the one metal strip. Small hole is created. Small hole, very, very important. Small hole. Small hole is created. It is heat temperature. T1 degrees to T2 degrees. T1 degrees to T2. So the hole of radius increases or decreases? Increases. So temperature increases T1 to T2. So radius also increases. How, sir? So actually this is the some intermolecular distance. This is the some molecules or atoms are present. Molecules are present in a metal plate. So for example, these are 10 or 20 molecules are molecules are present. It is heated. Move the distance between what is this one? Any metal plate is heated. The distance between intermolecular distance increases. Intermolecular distance increases. And this is the both are distance increase. This is also increase. They also increase. All are increases. So radius, radius of the hole increases. Because radius of the hole increases because intermolecular distance increase. On heating, intermolecular distance also increase. Okay. This is the one concept. Another one. So this is the metal plate. So two rings, two holes. This is the R1 radius, this is the R2 radius. This is the D distance. D distance between them. Okay, on heating at high temperature from T1 to T2 degrees on heating. So R1, R2 and D also all are increases. All are increases. R1 increases, R2 increases, D increases. Sir, R1 increases, R2 increases due to above conditions are okay. But these increases, distance between that both are decreases, sir. How sir D value increases? Okay? No, all are increases. R1 increase, R2 increase, D also increase, on a D also increase, the D also increase. How sir? So this is the whole. Okay, same intermolecular atoms or molecules are present. So at the radius, at whole. So each and every molecule move some distance, free to move. So distance it is move. So radius increases. These are radius increases. In between them also 10 or 20 molecules are present. Okay. This is the hole. This is the another hole. So the hole between two holes is 1, 2, 3, 4 number of atoms are there. Each and every atom also increases. In between them also molecules increases. This is also move. This is the move. So this is also D value also increases. Okay, in between them molecules also increases. Move. You cannot distance between molecules also. You cannot increase. So D also increase. So all R1 increase, R2 increase, D also increase. Okay. Right. This is the important concept. This is one very important.
Sir? Sir, మీరు కొన్ని ఎక్స్ట్రా ఫార్ములాస్ ఇచ్చారు కదా సార్?
ఇచ్చాను
సార్. ఆకాశ్ మెటీరియల్ లో కనబడట్లేదు సార్.
ఉండగా అది ఆకాశ్ మెటీరియల్ ఎందుకు ఉంటాయి?
ఓకే సార్.
ఆకాశ్ మెటీరియల్ ఉండవునా అంటే నేను అదేనా పేపర్స్ ప్రీవియస్ పేపర్స్ డిఫరెంట్ బుక్స్ అది ఒకటి 1 or 2 1 కాదు. ఓకేనా?
యా సార్.
రైట్. First notebook read each and every one, every point read, every point important, every point read. So after that you try problems, second exercise, third exercise, first more concentrate, first exercise, second exercise, next third exercise. So workbook, first exercise, second exercise, workbook, next third exercise. Right. So R1 increase, R2 increase, D is the distance between the holes also increase. Right. Next one, 3 rods. For example, 3 rods. So 3 rods arranged in the right angle triangle, identical rods. 3 identical rods arranged in the form of equilateral triangle. Right angle triangle. It is heated. Certain temperature from, for example, from room temperature 28 to 40 or 60 degrees C. 28 degrees C to 60 degrees C. For example, 60 degrees. 60 degrees C. From 28 degrees C to 60 degrees C. So, 60 degrees C. So, change of, this is the area change or, so no change of this is an angles now. Angles of no change. Angles also same angle. No change. The angles also no, okay, no, same remains same. It is heated 100 degrees also no change. Because, so there is no intermolecular distance move. Intermolecular is not a free. This is all are joined. Only all are joined. So without any change of angles. Angles remains same. So for example, we break, any or break, this is also expand freely. So this expands. It is easy, but without any break. So all is a continuous path. So continuous path without any intermolecular distance present. So remains same at any temperature. Remains same. No change of angles. No change of angles. Right. Next one. Next, this is the general applications. General applications of solids. Railway tracks also delta L equal to L alpha delta T. L alpha delta T. So L alpha delta T. Okay. This is the general applications. Maximum general applications of solids. Maximum covered. Okay, maximum covered. General applications.
Okay, sir.
Right. Only one concept, only measuring scale. Only one concept. So tomorrow we'll continue measuring scale, only 39. Okay.
Okay, sir. Thank you, sir. Bye, sir.
Okay, bye now.
Distance symbols completed very quickly.
Maximum completed solids. Tomorrow liquids. Start.
Sir, extra class you will take, sir.
No need, Anna. No need.
Okay, sir.
Okay, Anna. Bye.
Bye, sir.
Bye.
Thank you, sir.
Bye, Anna.
Sir, liquids
So,
are-